There we go. Hopefully that's good to go. Okay. So guys, let's start with fractions of an amount. Now, when we start, well, when we have to deal with a fraction of an amount, there's like a simple rule. And I think you guys are going to be pretty aware of what this rule is. It's divide by the bottom and then times by the top. Okay. And by putting that into action, let me just write this up here as well. Divide bottom. Okay. And then times top. I'm going to put that into action now with this, well, with these two examples. So calculate 4/9 of 27. Okay, so 27, we divide it by the bottom number. So the bottom number in this case is 9. So I do 27 divided by 9, which gives me 3. And then with the 3, I then times it by the top number, which is 4. So I do 3 times by 4, which gives me 12. Excellent. Yeah, divide by the bottom, get your answer, and then times it by the top. And we do the exact same, even if it's a top heavy fraction. Okay, so we take the 40, we divide it by the bottom number, which is 5. We do 40 divided by 5. That gives me 8. And then we times it by the top number, which in this case is 11. 8 times by 11 gives me 88. Okay, perfect. Divide by the bottom times by the top. And that goes for just literally every element of fractions of an amount. If you have an amount, divide it by the bottom, times it by the top. Okay? That's pretty standard. Okay? What I've got for you guys from the exam questions are worded fractions of an amount questions. So remember, divide by the bottom, times by the top. When you're dealing with percentages, it's actually not too bad if you have a clear process of what you want to achieve with it. So when I'm working out a percentage, I create like blocks in my mind. So I create things I want. So I want a 10%, a 5%, and sometimes I may want a 1% value, okay? And then when I've got those values, I can build them and put them together to give me my overall percentage that I'm after. So let's take, for example, 35% of 120. Okay, let's say I want to start with 10%. Now, I encourage all students to start with 10% because it's quite a nice one to get to. So when you're working out 10% of a number, essentially what you're doing is moving the decimal point one place in, okay? Now, if it ends in a 0, you're essentially getting rid of that 0. That's essentially what you are doing. Well, mathematically, you're moving the decimal place in and you're dividing it by 10. So 10% of 120 is 12. Okay, now I know at one point I'm going to need a 5% because I'm after 35%. So it's going to help me if I have a 5% value. Now, I'm going to ask the chat here actually, how do I work out 5% using what's on the screen? So if I know 10% is 12, how can I work out my 5%? All of your suggestions are welcome. Half the number. Yeah, half the 10% value, half the 12. Yeah, is that what we're saying? So half of 12 is 6. So if 10% is 12, 5% must be 6. Now, they're my building blocks. I can now build up to create the percentage that I'm after. Okay, I'm going to change the colour of my pen here just to make it stand out a little bit more. So I'm after 35%. So how many 10% do I want? Well, I want 3 of them. Okay, because 3 lots of 10% will give me 30%. So 12 times by 3 is 36. So that's let me put that in brackets here, 30%. I've got my 5% value, which is 6. If I add those two values together, that's going to give me my overall percentage, which is 42. And that would be worth at least 2 marks in an exam. So 42 is what we're after, okay? So create your building blocks, which are here, and then add them up, times them, whatever you need to do to create your final percentage. And then 43%, let's get stuck into this. So 43%. Well, what am I doing? Why have I put them before that? I've already got the question on the screen. Okay, 10%. Always start with your 10%. So 10%, once again, move the next point one place in or crossing off that 0. So 10% is 360. Okay, let's look now. I'm going to need a 1% because a 1% value will allow me to get 3% quite easily. Okay, so what do I need to do? Well, I need to divide it by 100, which essentially involves moving the decimal point 2 places in, which gets rid of that second 0. So 1% is going to be 36. Now I've got those values, I can then build that up to give me my percentage, which is 43%. So how many 10% blocks do I need? Well, I need 4 of them. How many 1% do I need? Well, to get from 1 up to 3, I need to times it by 3. Okay. Now what I'm going to do over in this corner here is do my maths, because this could be on a non-calculator paper. So 360 can be split up into 360, timesing it by 4. So 4 times 3 is 12 with 2 zeros, and then 4 times 6 is 24 with 1 0. Add those two values together, I get 1,440. Okay, so I'm mimicking what I would do on an actual paper. That's my 40%. And then finally, for my 3%, 36 times by 3. So once again, let's split up 36 into 30 and 6. And we're timesing that by 3. So that's going to be 90 and 18, which together gives me 108. And that gives me my 3%. If I add those two values together, I'm going to get my final answer. So 0 add 8 is 8. 4 add 0 is 4. 1 add 4 is 5, and then 1 on its own, 1,548. Now, you can look at the different, there's a bit more complexity with that question. So I like to think this question here could be worth 3 marks in an exam, because you're dealing with much bigger numbers and you're dealing with minor percentages, 1%, okay? But that's essentially what you need to do. That should be your process. Is step 1, identifying your 10%, your 5%, or your 1%. Then build those up into the percentage you're after. So if you're after 80%, then you find out your 10% and you times it by 8, for example. Okay. Now, what I've done yesterday, yesterday afternoon, went on to Exam Pro, which has got all the questions on there from past papers and random papers, and I selected a few different fractions of an amount questions and percentages of an amount questions, so you can see exactly what they look like in an exam, so you can have a little play with those. Okay, so I'm going to get you onto Desmos. I'm going to give you plenty of time to answer these questions, and I want you to see what you can do. Okay, so for those of you who haven't been on Desmos before, click on the link that I've just put into the chat, enter your name. Well, actually, you should continue without signing in, then enter your name, and then you'll be hit with the questions, and it slides 1 to 4 that I'd like you to work through and have a play with. Okay, try and arrive at answers that you are confident with, that you think are the correct answer. Okay, and if you can do that, then we'll all be in a pretty good place, I imagine, because I think you guys are a good bunch of students. Yeah, there's a nice selection there all the way through from start to finish. Off we go. I'll leave that slide on the screen for you guys, so you've got it available to you. Excellent. You can see Mo, Lottie, and Darcy. Excellent. You're where you need to be. Everyone else, there's a link in the chat that takes you to Desmos. Please click on that, because then you can actually see the questions. Excellent, Nicole. You're there as well. Brilliant stuff. Okay. Any questions? Feel free to message me directly. I've got my phone handy so I can see them, and I'll do my best to get back to you as soon as I can. Okay. Hey Lottie, there's questions 1 or slides, should I say, or pages 1 to 4. So all the way to the very end, which the last question, it is, should be this one. Let me just double check. Yeah. No worries. Okay, guys, just checking in with you all. I can see a few of you are on the last page. I want to give you guys another 2 minutes to try and get onto that point. So another 2 minutes, try and do what you can on the last page, and then we'll go through them, okay? But don't rush, take your time, and if you need to, just ignore me and keep working through it. Even when I'm going through the questions, if you want to ignore me, because this is being recorded, so you can watch it back and check your answers later. But if you have finished all the questions, please go through your answers, check them, make sure you're happy with them, to make sure you picked up the marks that you need. Yes, Mo, I can see you've said my name.
Slide 2, I don't know how to do it.
Slide 2. All right, let me have a look at slide 2. Ooh, yes. Slide 2 is a tricky one. It's like a problem-solving one. I'm going to go through that, though. I'm looking forward to doing that one. I think when you see it, Mo, you'll be like, oh, okay, I get you now. And I think slide 2 is a 3-mark question as well. But no, thank you for letting me know. I appreciate that. Okay, right, another 90 seconds, and then I'll come back and we'll go through these questions. So 90 more seconds, guys. Okay, guys, bring your attention back to the PowerPoint now. I'm going to go through these questions as best as I can. We'll review these questions together, okay? Right. Exam questions. So these 2 questions on the screen that you can see here, they're both 2 marks, okay? Because they're both fractions of an amount of questions, and you need to do 2 things in order to get the right answer. So it says here, the average age of teachers at a school is 36 years. Mr. Smith's age is 11/9 of the average. How old is Mr. Smith? Well, in order to work out that, we need to work out, well, the average age is 36, and we need to do 11/9 of the average. So we need to do 11/9 of 36. Remember, divide by the bottom and then times by the top. So 36 divided by 9 equals 4, and then 4 multiplied by the top number, which is 11, gives me 44 years. So our good friend Mr. Smith is 44 years old, and I can see a lot of you there have got 44 on Desmos, which is excellent. In a game, the average score was 50. Tom's score was 5 halves or 5 twos of the average. Okay, what score did he get? So once again, divide by the bottom, which is 2, and then divide and then times by the top. So 50 divided by 2 is 25. 25 times by the top number, which is 5, gives me 125. So you're dealing with a slightly bigger number there in the fact that the division was 25. But take your time and you will arrive at the right answer. If you do that every time, divide by the bottom, times by the top, you will have success, okay? Now, this is the question Mo said it was quite confusing, so I'm going to go through that now. So we've got Zoe. She's thinking of a number, and 3/10 of 90 is equal to half of her number. What is the number she is thinking of? So what we need to do is start with this bit here, 3/10 of 90. So once again, divide by the bottom times by the top. So 90 divided by 10. That tells me that 1/10 is 9, but I want 3 of them. So I'm going to do 9, I'm going to times it by 3. That gives me 27. So what do I know? Well, I know that this here is now 27. So 27 is half of her number. So what do I need to do to 27 to get to her number? If I know that 27 is half of a number, what should I do? To find out her missing, or to find out the missing number. The lot is saying double it, and that is correct, because if it's half, we need to do the opposite, so we double it. So we times it by 2, which gives me 54. Now, in an exam, that is worth 3 marks, that question, because you've got to work out your fraction amount, double it, but you also need to have that problem-solving awareness to know what to do there, okay? But worst case scenario, you guys are all capable of achieving a mark or 2 for getting to 27, okay? By dividing by the top, by the bottom, and times it by the top, okay? We're now going to look at the percentages questions. So once again, you can see here 2 marks. Standard behavior here, when you're working out percentage amounts, they're at least worth 2 marks, okay? So 21% of 56. Well, straight away, I'm going to work out 10%. Okay, so 10%, let me take 56 here. 10%, I've already wrote 10% on the screen. I'm in autopilot, guys. There we go. Let me start again. 56. So 10%, move it across 1. So it gives me 5.6. Okay. Now, 1%, we have to move the decimal point 2 places across. So it goes across once more. So it becomes there. So it becomes actually 1% is 0.56, which is really important for us to establish. Now, we want 21%, okay? So what do I need to do? Well, I need to take my 10% and times it by 2, which in this case gives me 11.2, okay? Now, what I need to do is add on my 0.56, then that will give me my total for 21%. So that's going to be 6, that's going to be 7, and then the rest of the number will be 11 as well, like that. So 11.76. Now, I actually think that question there, looking at it, would probably be on a calculator question. If I'm honest, I'm looking at that now and I'm thinking probably a calculator question. Unfortunately, when I take it off the site, I don't know which one it is. But yeah, I can see a few of you have got 11.76, which is good, and you're in the right ballpark there, which is really encouraging for me as your teacher today. Okay, but yeah, if you've got 5.6 or 0.56, that's going to give you at least 1 mark. 11.76 gives you the 2 marks. Now this one, slightly more straightforward. Okay, and I think you guys will appreciate this one slightly nicer. What we need to do is work out 10% and then times it by 8. Okay, so work out 10% and then times it by 8. So 10% of 300 is going to be 30. Times it by 8, give me my 8%. So 3 times 8 is 24. Chuck on the 0, 240. So the reason why I think this would probably be on a calculator paper, the one before, look at the level of complexity compared to that, compared to doing that, and it's both worth the same amount of marks. So I think this one here more likely to be on a non-calculator paper, but the one previously more likely to be on a calculator paper. Right. This one's interesting, this question. Do you know why? Because it's actually given you some percentage to work with already. So I'm going to sit back actually a second here in the chat, and I want you all to put in some answers. I don't want it just to be one person. I want you to all just, and if someone's written it before you, ignore them, write your own thing. What do you think I need to do? Because I've been told what 5% is. I've been told what 1% is. How do I work out 13% using that information? So just type away. I'm not going to look, actually. I'm not going to look at the chat for like 30 seconds or so, or a minute, and just let you guys type away, okay? Okay, I'm going to look at the chat now. Add the numbers people are saying. I can see Tom's typing something. Maybe, was he? What we need to do, I see Tom's still typing, that's good. I can see when people are typing, that's quite handy. So Lottie told me the process. Okay, let's have a look. Right, I want 13%, okay? And I've been told that 5% is 31. Yeah, 5% of a number is 31. 1% is 6.2. Okay, that's what I've been told. So 5%, and I want 13%. So what I need to do now is how can I use this information here to get me up to 13%? Well, 5%, I can double it, can't I? If I times that by 2, that gives me 62, which gives me 10%. Yeah. What do you think I need to do to this, to the 1% value? Excellent. Nicole's read my mind. 1% times it by 3. Excellent, Nicole. Yeah, so I times that by 3. Now, 6.2 times by 3. Well, 6 times by 3 is 18, and 0.2 times by 3 will be 0.6. It's going to be 18.6, and that gives me my 3%. My final step is to add them together. So that's going to keep a decimal point, and that's going to be 6. 2 add 8 gives me 10, so 0 and carry the 1. 6 add 1 gives me 8. My final answer is 80.6. Now, why is that question difficult? Because it actually gives you some of the information already, and it catches students out because it ruins your flow. Because normally you've got a set routine, find 10%, find 5%. So when this has already been given to you, you're like, hang on a second, what am I doing here? But yeah, try and pick up from where they started you off on, okay? But 80.6 is my final answer. Now, I think you would get marks for 62, and you would have got a mark for 18.6, and then 80.6 gets you all the degrees, all the marks in the bag, okay? But yeah, feel free to comment on that, guys. What do you think to that? Then we've got the last little question, or last question here, A and B. So this was literally spliced from a paper, A and B, 4 marks for this paper for working out your percentages and your fractions. So let's have a look. 11% of 1,400. Well, 10% would be 140, and 1% would be 14. If I add those two values together, that would give me my 11%. So that's going to be 154. Happy days. And then the final one, remember what I say, divide by the bottom, the 295 divided by 5. Now, we're going to use this non-calculator style. Are you ready? Bus stop method. 295 divided by 5. Let's change the colour of a pen. Let's make it stand out. All right? How many 5s go into 2? 0. Carry the 2 across. How many 5s go into 29? Well, 5 of them go in, and there's a remainder of 4. Then my final question, how many 5s into 45? That is 9. So I've got 59 for that. And then the bit next, we have to times it by the top. So you have to do 59, and we times it by 4. Now, once again, this is a non-calculator paper. Let's assume it's non-calculator paper. So non-calculator methods for multiplication. I like to use the grid method. So I'm going to do 50 and 9. I'm going to times it by 4. I don't actually need these bottom bits. 4 times 5 is 20. Chuck on the extra 0. 4 times 9 is 36. Add those two numbers together, we get 236. Bada bing, bada boom. 2 marks. 2 marks. So divide by the bottom and times by the top to allow you to get a fraction of an amount question. Work out your building blocks, and that will allow you to get your percentages questions. Now, the difference between the good, the best, and the worst students with regards to this is practice. If you practice these questions and these skills repeatedly, time and time again, you will become a master of them. You will have them in your back pocket, and you will have success. If you leave this skill, if you don't really work on it or practice it, then it's something that we tend to forget, and we don't want to forget. Okay, but you guys are looking pretty crafty. We're looking pretty good on these. We're now going to look at something called percentage change. Percentage change, okay? Now, let me try and explain what percentage change is. In life, things go up and down in terms of money. So, for example, you might walk past a coat in a shop and it's £100. The next day you go past and it's worth £70. We know that it's reduced by £30, but sometimes we like to talk in percentages. So I saw a percentage headline the other day, actually, that the cost of inflation has gone up by 7%. Now, what that means is that generally most things have increased in value by 7%, I think. Okay, I'm not a great finance person, but yeah, percentages allow us to understand growth or change in terms of something quite transferable across many things. Now, there's a strategy for percentage change, and that's this up here. We have to work out the difference between the values. We then divide it by the original value, and then we times it by 100. Now, I have a calculator for this. You guys are allowed to use a calculator for this because I have chosen calculator questions. But step one, work out the difference between the two values. Okay, so they're my values there, 25 and 18. Actually, no. I'm getting ahead of myself. Let me read the question. The number of customers that a food truck receives for lunch drops from 25 to 18 over 2 days. What is the percentage loss in customers? So the difference between these two numbers. What is the difference between 25 and 18? Well, 25 take away 18 is 7. So that is my difference. What is the original value? Well, the original number of customers is 25. It was 25. So it's going to be 7 divided by 25. Okay, so 7 divided by 25 is 0.28. Okay, 0.28. The last thing I do is times it by 100, because then that converts it into a percentage, which gives me 28%, like so. So, difference between the values, you divide it by the original value, the original number in the question, and then you times it by 100. Let's do another example. So, a visualizer. It cost £40 last year. This year, it now costs £95. What is the percentage increase? So how much has that gone up by in terms of a percentage? Well, what is the difference between 95 and 40? Well, the difference between those two numbers, 95 take away 40, is at 55. So that's the difference. We divide it by the original cost. So originally, it cost £40. So I do 55, I divide it by 40, and that gives me, funky here, 1.375. What do I need to do? To convert it into a percentage, times it by 100. So I take that answer and I times it by 100. That gives me 137.5%. So it's gone up by quite a lot, hasn't it? So yeah, percentage change. Work out the difference between the two numbers, divide it by the original number, and then times it by 100 to get your percentage. Okay? Now I've got 4 questions for you guys to do. I'm going to leave this example on the screen because I think that's quite a nice example. I think I've written that out quite nicely. But yeah, I'm going to get you guys to work through this as best as you can. You can use a calculator. You can take all the time you need. Work through these to the best of your ability. There's a link to Desmos again if you've clicked off of it. But if not, jump back in and try and get 4 answers that you believe are absolutely spot on. I'll go through each and every one of them. So let's see if our matches match up, or see if our answers match up when we go through them. Okay? But yeah, guys, get stuck in, get your answers submitted onto Desmos as well so I can see how we're genuinely getting on. All right? Crack on. I'll catch you guys in a moment. Okay, guys, what are we saying? Mo, what would you like help with? Which is there a question in particular or in general?
For the question C,
Question C. So that is a puppy. Okay. So what is the difference between those two weights? 2 kilograms and 3.5.
is 1.5.
Perfect. So 1.5. What was the original weight of the puppy?
2 kg.
Good. So you do 1.5, divide it by 2, and then times
Is
it by 100.
is
Go on.
75.
Yeah, perfect.
How? Like
What do you
how
mean
is
half?
75?
It's gained 75% of its weight.
Oh, okay.
Yeah,
Cheers.
that's right. That's fine. It's good though, because even if you weren't sure, like you're like, I've got the number 75. I don't think it's you got the right answer. So as long as your strategy's there, the understanding can come later. Okay, as long as we're getting the right numbers, that's a good place to be. But I am probably. Let me scroll down. Because I was focusing on the top one for a second. Then I'm gonna wait another 30 seconds. Try and get a few more answers, guys. I'll refresh Desmos to make sure I've got the most up-to-date numbers, and then we'll go through each one of these. We're looking mixed on some of these, so I will go through it and take my time as best as I can. But we're looking mixed, and then sometimes we're looking quite in agreement, in accordance with each other, which is good. Okay. Bring your attention to the PowerPoint, and we'll have a little chat now. So, percentage change, percentage increase, percentage decrease, right? Essentially, you need to remember that top rule. It's the difference between the two values. You divide it by the original, and then you times it by 100. Okay, you do that every time, you're good. You're going to work out the percentage difference quite comfortably. So the price of a toy usually costing £50 is increased to £65. Work out the percentage increase. Okay, so if we've got £50 and £65, we need to work out the difference. And the quickest and the most effective way to work out the difference is by doing the larger number, taking away the smaller number. So 65 take away 50 gives me £15. So the difference between the two prices is £15. Okay, we take that £15, and now what we do is we divide it by the original cost. Now, the original cost of the toy, let me get rid of those circles, was what it cost at the start. So at the start of the question, basically, and we can see there that it's £50. Okay, let me highlight that in yellow so you guys can see that. £50 it started with. Once we've got that, we can then actually substitute that into the formula. So 15 divided by 50. So use your calculator at this point, make sure you get the number absolutely spot on, and that gives me 0.3, which is quite handy. But we have to do one last thing. What's the last thing we need to do in order to calculate it and give my answer as a percentage? What's the last thing I need to do? Times it by 100. Excellent, because if we ever want to turn a decimal into a percentage, we multiply that number by 100. Okay, so 0.3 times by 100 gives me 30%. So what does that mean? It means that the cost of the toy, its value increased by 30%. Okay, that's essentially what it means. So instead of us saying, oh, £15, we can say, yeah, increased by 30%. We can use the percentage to describe that change instead. Good stuff, guys. Good start. So hopefully you guys making notes on this. If you got it right, give yourself a tick. If you haven't, then quickly copy down what I've got at the bottom here, because they are the numbers you need now. What I was going to say, it's going to come up on either paper 1 or 2. So it could be a non-calculator paper or a calculator paper. Okay, so we've got to be prepared for being able to use a calculator or maybe not using a calculator. Next question. Here we go. The price of a new car was £12,500. It is reduced to £11,625. Work out the percentage reduction. So once again, start by working out the difference between the two values. So we've got 12,500 and we've got £11,625. Best way to work out the difference is doing the larger number, subtract the smaller number. So 12,500 take away 11,625. We'll use the calculator now and put that in. So 11,625. I'm making sure I'm doing the numbers right now. What you don't want to do is put the numbers in wrong on your calculator, because that's something that we can definitely and quite easily avoid. The difference between those two values is £875. Okay. Once we know the difference, we can then put that into our formula that we had earlier. So 875, we divide that by the original cost. So the car originally cost £12,500. So 12,500. So put that into my calculator now. 875 divided by 12,500 gives me 0.07. 0.07. And I'm going to use what Nicole said earlier. When we hit this point, and we know we've got a decimal, and we want to convert it into a percentage, we times it by 100. So 0.07 times by 100. Oh, Nicole, you're doing the work for me. I like that. 7%. Okay, so we have our 7% increase, or deduction, sorry. It went down by 7%, okay? There we go. And that, unfortunately, guys, in life, you'll notice cars do go down in value, okay? Unless you get a very rare classic car, but unfortunately, the majority of them will go down in value. Okay, this was number 3 then, or question C. This involves a little puppy. A puppy weighed 2 kilograms, okay? 8 weeks later, the puppy weighed 3.5 kilograms. Calculate the percentage increase in the puppy's weight. So me and Mo, we talked about this one, didn't we, a moment ago? We worked out the difference between these two values is 1.5 kilograms. Excellent. Yes, Nicole. Yeah, good. 3.5 take away 2 gives me 1.5 kg difference. So that's the difference between the two values. What is the original weight of the puppy? What was the original weight? 2 kilograms. Excellent. So I'm going to do 1.5. I'm going to divide it by 2. So once again, taking my time on my calculator, make sure I'm doing this properly. 1.5 divided by 2 gives me 0.75. That's my difference in terms of a decimal, but I'm after a percentage. So I times it by 100. Okay, 0.75 times by 100 gives me 75%. So essentially that puppy gained 75% of its body weight. That's what led to its increase in, or that's what led to its new weight, okay? And then the last question, 99% sure this would appear on a calculator paper, given the fact it's got some juicy decimals involved. We've got Alice, and she buys a book. She buys it originally for £19.80. A year later, she sells the book for £12.87. What is the percentage decrease? So work out the difference between the two values. The biggest number, subtract the smallest number. That will give you your difference. 12.87. So once again, in a calculator, there we go. £6.93. £6.93. That's the difference between the two values. So I'm going to put that into my little formula now. So 6.93 divided by the bottom, divided by the original. So the original cost of the book when she first bought it was £19.80. Okay, so £19.80. Yeah, I highly imagine this would be on a calculator paper. So 6.93 divided by 19.80 gives me 0.35. But the encouraging thing here is it's quite a nice decimal, which means we're probably along the right lines. Times it by 100 to convert it into a percentage, and we get 35%. So the book lost 35% of its value over a year. Okay? Excellent, guys. Good stuff. I can see Nicole, Mo, excellent, brilliant, guys. Really good stuff. Now, that is percentage change. Now, if I go back a few slides, it's all about this top tip. Because it worked. You notice then it worked every time. If you learn that strategy, if you learn this here, okay, you will be in such a strong position, okay? Such a strong position. So, difference between the two values, divide it by the original value, and then times it by 100. You'll get a correct answer, Okay, so have confidence in learning that ability, learning that skill and that method, because it will transfer into marks, and we want as many marks as possible. We are now going to look at something which I'm quite excited to do because I think it really does challenge us in a mathematical way. It's called forming and solving equations. Okay, now this is going to require you guys to be very focused and very switched on because it involves different areas of maths. It involves a little bit of geometry and it involves some algebra. Okay, so it involves two different area of maths coming together to create a question. Now, these questions tend to appear towards the middle, towards the end of a paper. And these are the marks you want to try and get you as close to the grade you're after, especially if you're looking for a grade 4. If you can pick up these sort of marks, really does put you in a strong position. Okay, so listen carefully, feel free to make notes, and then I'll do my best as a teacher to explain it as best as I can. Okay, are you guys ready? Yeah? Okay, good stuff, good stuff. I'm just taking your silence as a yes. Okay, we have 4 lines here, and they meet at a point. So the first thing I'm going to ask you is, what do angles at a point add up to? What do angles at a point add up to? What do they all need to create? Angles at a point. Feel free to, chuck an answer in there. You've got nothing to lose at this point. We've got a nice little point. What do these angles create? Lottie is saying 360 degrees. And Lottie would be absolutely spot on. So these 4 angles here, when put together, would give me 360. Hey Mo, I like your attempt there. Not quite 180. 180 would be if it was a straight line. Okay? 180 would be a straight line, but because we've got angles at a point, it would be a circle, which gives me 360 degrees. Okay, so 360 degrees. Now, what I know is that if I added these, these expressions and these numbers together here, if I added those 4 together, it would give me 360 degrees. So what I'm going to do, I'm going to write that out. Okay, now you may be thinking, what do you mean write that out? Have a look. I've got 20 degrees here. I'm going to add it to 4x. I'm going to add on 100 degrees there. I'm going to add, finally, a little x on the end. And what do I know? That all of those things, all of these 4 things here, when they're added together, would add up to 360 degrees, okay? So hopefully you guys can see that. And if you can copy this down, that'd be brilliant. Now, linking back to what we did on Tuesday, where we grouped our expressions and our terms together, that's what we're going to do now. So I'm going to put all my degrees together. So I've got 20 degrees and 100 degrees, okay? And I'm going to circle them just so it stands out very clearly, but I'm also going to include the symbol to the left, okay? So I've got 20 plus 100, that will be 120 degrees, okay? And then what do I do next? Well, I'm going to put together my x's. So I've got 4x plus x. What is 4x plus x? In the chat, guys, what is that? Go on, someone said that there, nailed it then. 5x, yeah?
5x.
Legend, good. 5x, good stuff. So we've got that now. So group them together, nice and tight, and we're going to say that equals 360 degrees. Now, what we've actually got here is an equation. And what can we do with an equation? We can solve it. Okay, we can get it down to give me the value of x, which is what we're after. Okay, so how do we do that? Well, normally we see 5x plus 120, but let me rewrite that. So I'm going to do that. I'm going to put 5x plus 120 because I think that's more commonly what we see. Now, in the chat, what would you guys do first here? If you had 5x plus 120 equals 360, what would you do first? If that was just a question, what would you be thinking, or what would you do? Get rid of the x from 5 minus 120. Right, I'm going to take Darcy's answer. So Emma, I'm taking that one down. I'm getting rid of this bit first. Because the 5x is pretty tight, okay? But the 120, because it's just kind of floating there, we know exactly what it is. We can get rid of it quite comfortably. So I'm going to get rid of the plus 120. So I'm going to get rid of the 120 from this side. And as Lottie said there, on each side. So I'm going to take away 120 from this side as well. So I'm subtracting, or I'm getting rid of, essentially, the 120. And I do it to both sides to keep it balanced. Okay, so what does that leave me with? Well, that leaves me with 5x by itself on this side. And then on the other side, 360, take away 120, leaves me with 240 degrees. Excellent, Lottie. Now, Lottie's seen the last little step. We've got 5x. That means x is being times by 5. When we solve an equation, we do the opposite. So we divide by 5 this time. And once again, we do it to both sides. So on the left-hand side, we're going to be left with just x. And then 240 divided by 5 gives me 48 degrees. Now, it says here, find the value of x. Look at the very bottom. Look what we've just done. We have said that x equals 48. We have found the value, and we've got it absolutely spot on. So why this question? If you're looking up, that's quite tough, that was. That's fine. This is probably the first time you've been introduced to it ever or for a long time. So it might be the fact that you've not seen something like this before. But don't worry, we're going to practice it. We're going to try and make it so we have some confidence with this sort of question, okay? Now, what we could do, and the question might say, what's the size of this angle or the smallest angle or whatever it may be? You can substitute x back in and then you can work out some actual values. We won't do that today because we will be coming on to that in a short while. But yeah, for now, let's just focus on getting x equals as our final answer, okay? Now, I'm trying to work out if I've got another example. I do. Haha. Okay, I've got another example here. I can see Mo's typing something, so I'm going to let Mo finish that sentence or two off. But in the meantime, if you guys are ready to move on, copy down this diagram for me. Yeah, Mo, of course you can. These are just opt-in sessions. If you want to come back to this later, watch the recording, that's absolutely fine. But yeah, thank you for letting me know. So what I'd like everyone else to do, who's sticking around for a little bit longer, to copy down that diagram for me. Now, proper juicy question this. I enjoy these sort of questions because I really think it allows you to flex your mathematical skill, okay? It's okay, Mo. Thank you for dropping it. You've been excellent these last few ones. Okay. So Lottie's already thinking now, what do these equal to? Right. This is a four-sided shape. Angles inside of a four-sided shape add up to 360 degrees. If it was a triangle, Lottie, I'd completely agree with you, 180. But because it is a four-sided shape, the angles need to add up to 360, okay? So what I'm going to do, I'm going to start putting these together. So I've got x plus 30 degrees, that one, included that. Then I've got 3x plus 20, so add 3x plus 20, add 3x minus 10. What I'm going to do, give myself a bit more space. Okay, so 3x minus 10, yeah, got that one in, good. And then finally, plus x. Don't forget about the little x in the corner. All of those together give me 360 degrees. Okay, are we happy with that? Now, we've got a very long equation there. Now, to make our lives much, much easier, we need to simplify it. We need to put all of our x's together and then all of our whole numbers together, all of our numbers together. Okay, so how do we do that? We group them together. So x plus 3x plus 3x plus x. So I've got a few x's there, so I'm going to feel free, use your fingers, use your brain. X plus 3x, that's 4x, plus another 3x is 7x, plus another x, that's going to be 8x. Okay, 8x in total. And if you guys are already practicing this ahead of me, check that you've got 8x as well. And I've got plus 30, plus 20, ooh, minus 10. Okay, so 30 add 20 is 50, minus 10 is 4. Nicole, you are fast. Yes, we've got plus 40, okay? And that equals 360. Now, what I'll do to make this as neat as possible and as clear as possible, I'm going to write that bigger now. So 8x plus 40 equals 360. Why 360 degrees? because that's what angles inside of this shape add up to, okay? What do I do first? What are we saying? What shall I do first now? Thinking back to what we did first in this last question. What do I do first? Lottie, excellent. Well done there. We get rid of the 40. CMO. So we've got plus 40. I want to get rid of it. So I subtract it. Minus 40. And whatever we do to one side, we do to the other. Okay? So we are left with 8x equals 360. Take away 40. It's going to leave me 320 degrees. What's the final job? You go on, you guys can deliver this. What's the final task we need to do? The final step of the question. Divide by 8. Excellent. Now, I know Lottie's got the grasp of this. There's answers in the chat. But what we'll do, give you guys some chance to practice this in a moment to see how you're all getting on. So 320 divided by 8. Now, I have a gut feeling the answer is 40, which it is, but I'm using a calculator to back it up. So my top tip as well, just beyond this, in a calculator paper, if you doing a sum, use a calculator just to confirm it, just so you're not making any silly mistakes along the way. But x equals 40. There is my final answer. Look at that. I think that's such a nice, I love these questions because like I say, it allows you to show off to the examiner, I can do this. X equals 40. That's exactly what we needed to do. That's exactly what we've done. Happy days, okay? Right. I believe now you guys have some questions, okay? I'm just looking at the ones you guys have got. You guys have got quite similar to me, actually. You've got, yes, quite similar to me. You've got a four-sided shape, which we've just done. And then at the start, we did angles around a point, which you've got. Now, guys, let me just quickly refer back to this. What does this, where's my pen? Right, what does this mean? What does that symbol then represent? 90 degrees, excellent. So when you're doing your sums and your calculations, whenever you see a little square in the corner, we know that means 90. That means 90 degrees, okay? Right, on Desmos, you guys have got these two to do. So let me get you onto Desmos now where you can put in your answers. But for both of them, I want you to calculate the value of x. So in my perfect situation, x equals would be the answer line. If you don't quite get there though, but you do some of the things that I'm going to be doing on the screen in a short while, you can still give yourself some marks and give yourself some credit, okay? So don't worry too much if you're not getting the final bit, as long as you're doing some things right along the way, because every mark counts. So attempt these questions, give them your best effort, and then we'll go through them and we'll see if we're all, working towards making progress on these, okay? But I can see who's on there at the moment. We've got Lottie and Darcy and Nicole, excellent. Everyone else try and jump in, try and get in onto Desmos. Give them a go. You may be thinking, Sam, I don't like these. I really don't want to do them. I ask you just to give them a go. Okay, I'm not going to judge you. I'm not going to hold anything against you, but I'd like to see what you guys can create. Okay, right. I'll shut up. I'll let you guys focus and I'll see you guys shortly. Okay. Okay, guys, let me just have a look. So, have we got answers in where we want them to be? Or do you guys need a little bit longer? Let me know if you finished to say the word done. Excellent, I thank you. Okay, we'll go through these two questions then, and then we're going to do a finale one, okay? I'll do an example and then a finale. Right. So, the first question you had was a four-sided shape, wasn't it? Now, this is a quadrilateral. A quadrilateral is a four-sided shape. The clue is the fact it has quad. Quad means four. So a quadrilateral is a four-sided shape, and any quadrilateral in the world, the internal angles, the angles inside of that shape will add up to 360. Okay? What's wrong? Oh my word, my throat today. I've got a tickle. Right, let me try and do a cough to clear it. You ready? Embarrassing. Anyway, we've got 2x, 3x plus x. So let's start with 3x. 3x plus 2x plus x plus 90, because we've got 90 degrees in the corner. All of those add up to 360. Let's put all of my x's together. So 3x plus 2x plus x, that is 6x. 6x plus 90 equals 360. What do I want to do next? I want to get rid of the plus 90. And how do I do that? I take it away. So I subtract it from both sides. That leaves me with 6x equals 270. The last thing I need to do is to get rid of the 6. And I need to do that by dividing by 6. Okay, so 270 divided by 6 gives me 45. So x equals 45 degrees. Okay, now I'm giving myself 3 ticks there because I think that's worth at least 3 marks. Okay, so let me just go back. How many of us got 45? Few of us did. Excellent. I think what we may have done wrong is, so I think one of us has got x equals 60. So what I think we've done there is we've done 360 divided by 6, and we forgot to tackle the 90. So make sure we get rid of the little pluses or the minuses beside of the x value, okay? But no, that's still good. If you're getting to this point, really good, really good. We're building up a picture, and that's what we want to work towards. Now, this one actually isn't that bad. In fact, some of you may not even have to write it out long form, because you've said, right, well, I've got 3x plus x. So that's going to be 4x plus 90 equals, well, it's angles around a point, so that's going to be 360. So some of you may have been like, boom, 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 quick fire, and you've got that written down. Even really impressive if that's the case. Got a plus 90, so I want to get rid of it. So subtract 90. That's going to leave me with 4x equals 270. It's the exact same nearly. 4x equals 270. The last thing I need to do, and I'm getting my calculator ready to do this, is to divide by 4 on both sides. That leaves x equals 270 divided by 4 is 67.5 degrees. So don't worry sometimes if you get a decimal, because as long as the decimal is ridiculous, like a 67.526794321 degree, yeah, that would be a bit ridiculous, but 67.5, pretty concise. Okay, so pretty nice decimal. Right. I don't know if you guys are going to love me or hate me, but we're going to do this. Well, what are the difference between ours? Okay, we can do this. Are you ready? Last question. I'll do an example, then you guys are going to do one yourself, and then hopefully hopefully we've all got answers in and around the right area. Okay. Deep breaths. Deep breaths. The perimeter of this rectangle is 42 meters. Calculate its area. And we've not been told the sides, we've just been given algebra. So we need to use our knowledge of algebra to work out the length and the height or the width of this rectangle, okay? So, if the rectangle whole perimeter is 42, then what must half of the perimeter be? What must this side and this side be? If the whole perimeter is 42, what must one width and one length add up to? 21. Excellent. I love that. Good. So what I'm going to do, well, I know that these things, when added together, give me 21. So 2x plus 6 added to 3x minus 5 equals 21. So let's write that out. So 2x plus 6 plus 3x minus 5 equals 21 meters. Okay? So far, so good. Let's group them together. I'm going to use the highlighter here because I think the highlighter is a bit better. So 2x plus 3x. What is 2x plus 3x? So it's going to give me 5x. Okay, so 5x. Then what am I going to be left with? The whole number. So I'm going to ask you guys for this. I've got 6 minus 5. What is 6 minus 5? 1. Excellent. So it's going to be plus 1. 5x plus 1 equals 21 meters. Whoa! We've got an equation we can solve. Yeah, we've formed an equation. We can now solve the equation. Excellent, Nicole. Yeah. So how do I solve it? Well, I need to subtract 1 from both sides. That's step 1. Get rid of the plus 1 by taking it away. That leaves me with 5x equals 20. What do I do after that, guys? Divide. Excellent. I divide it by 5 because it's being times by 5 over here on the left. So I divide by 5. That leaves me with x by itself. 20 divided by 5 is 4 meters. Now, normally that would be fine. Like the last few questions, we said, yeah, perfect, that'll do. Now we actually need to use this information to help me work out the area. Okay. So how do I do that? A little something called substitution. Okay. So now I know what x is. I can now put it back into the terms up here. So instead of it being 3x minus 5, well, it's actually going to be 3 lots of 4 and take away 5. So 3 times 4 is 12. Take away 5 is 7. So I know that the width or the length, or whichever way you want to say it, is now 7. And then we can do the same on the left-hand side here. So instead of it being x, it's 4. So 2 lots of 4, okay, is 8. Add 6 is 14. Now, I've realised with this question, I've put them in the wrong order because that is definitely not drawn accurately. But we've got the length and the width. We've got the 2 numbers that we need. How do you work out the area of a rectangle? How do you work out the area of a rectangle? The base times height, or length times width. Okay, and we've got those 2 values there. So 7 times by 14. Now, I'm going to be lazy. I am going to use a calculator because I'm just that guy right now. But anyway, 98 meters squared. That is the area. So let me talk you through step by step what I've done there. Is I've worked out what those 2 sides need to add up to, and that was 21. I then put it together to form an equation. Okay, once I had my equation, I solved it and got a number. When I had that number, I substituted it back into the original sides up here. Okay. Oops. Let me get a pen. There we go. I substituted back up into these points here, and then I got a value. And then with those 2 values, I then calculated the area. Now, This is definitely, this is worth, I want to say, maybe 4 or 5 marks. But I think you guys, from what you've shown me just, you are able to achieve some of those, if not all of them. But it's just practice now, isn't it? I think the difference between really getting your head around it and having it in your locker and maybe not having it in your locker is just by practicing. So I'm going to give you that one to do. It's one straight off of the old block, off my head. Yours will look nicer than mine. So it's on Desmos. Let's see what you guys can create. Let's see if you can get the final correct answer. Okay, it's the last question of the day. So let's finish strong. Let's try and smash it, okay? Any questions, feel free to pop up or wait for me to go through it. That's absolutely fine. Hey Lottie, I've just seen your question. 4x, would you do 6 times 6? Ooh. The only reason why I'm like, ooh, is because I've not currently looked at the question yet. I've not done it yet. Do you want to send me a picture of you working out? Or if you're possible to do that, if you could, that'd be brilliant. And I can have a look. But I've not looked at this question yet. Two, 6. Okay, I can see that Darcy and Kate currently have the same answer from the answers on Desmos. It's another 30 seconds to try and submit your answer. can see Lottie is typing in an answer now. Ooh, so all three of you got the exact same answer, which is very encouraging. Suggests you're all right. But let's put it to the test, shall we? Put it to the test. Okay. So I'm trying not to have another like coughing fit. Let's see. I know that the full perimeter of this rectangle is 46 meters, but really I only need to know half of it to deal with the size that I've been given, which is this side and that side, okay? Because that's exactly half the perimeter, which is 23 meters, isn't it? So if I do x plus 2x plus 5, that equals 23 meters, okay? Then if I group that together, so I've got 3x plus 5 equals 23. I've got a nice, more simple, compact equation. So I want to get rid of the plus 5, so I take it away. So that leaves me with 3x equals 18 meters. Make sure we include the meters there. And then I divide by 3. If I divide by 3, that tells me what x is, which is, you know, crucial in terms of working out the area. So x is 6 meters. Now it's quite nice. It's a straight, easy swap there. So instead of it being x, I can now put 6 meters. And then up here, well, it's going to be 2 lots of 6 plus 5. Well, 2 lots of 6 is 12. Add 5 is 17 meters. So I know the height is 6. The width of this particular rectangle is 17. So to work out the area, base times height, okay, 6 times by 17 gives me 102 meters squared. Now, squared because we're doing the area, remember? So just change those units to meters squared by the end. Now, that is the answer. And from those that I can see, you managed to have success with that. That's very encouraging for me, because when I've done this in the past, lots of students, they struggle with this. It's a difficult thing. Like I said earlier, it mixes and matches algebra and geometry into one question, into one place. So to get your head around that is quite a challenge. But if you're having success, really good position to be in. We don't know how it's going to come up in the future, forming and solving equations, but it could and it might. So we need to be prepared. So you guys putting in that time and effort and the energy today, hopefully sees you well in the future. Okay, I do appreciate it. And for anyone who's watching on YouTube right now, because you're watching the recording, hopefully you found the session useful and beneficial as well. But that is us at the end of the lesson. You guys have been phenomenal today. I've appreciated your input. You've kept me company through the chat. And although we're not due for, like, you know, it was a 2-hour session, we've done it in an hour and a half. Hopefully you found that hour and a half beneficial. You guys are free to go. I'm going to tidy up now. I'm going to record the session, stop the recording, and get it onto YouTube. So there we go. I might become YouTube famous, who knows? But guys, thank you for being here today. I appreciate it as always, and hopefully see you guys soon in college next week at some point. All right, see you guys in a bit.